Okay, what questions? Do I feel that copying in and out of these temporary things could become a performance problem? Not really. It's going to be probably faster than allocating no matter what. Um, but also, most of the usage of temporary storage you probably don't want to copy, right? Like all that file name stuff and generating name of a sound effect and stuff, you don't actually want those to survive very long, right? Those things are meant to go away shortly after you use them. So in fact, so far, I have not in the Sokoban game ever copied anything out of temporary storage. I just haven't needed to yet. Do I need to ban this Quartertron guy? What's going on? Why is everything deleted? I will happily ban someone if they're spamming, sorry. I don't like timeouts. If someone's spamming, just kick them off the channel. Like I have very low tolerance for that. Would it be beneficial to set a mark on the temp storage on a function like the player moving things, like the one you showed earlier? Maybe. You know, it just depends. What that is just a tool for keeping the temporary storage small. I don't tend to want to think too hard about it. So I would maybe put it at the start of any major section. Yeah, I mean, I haven't, I haven't done that too much yet. I don't. So the thing about using a temporary storage like this is if you're ever wrong, then you've introduced a bug. And there can be things in the runtime to help you find those bugs. Like when you pop back to temporary storage, we could like wipe that page with a known pattern and stuff in debug builds. But you just don't want to have bugs like that, right? And so I think you still want to be kind of chill about it. You don't want to try to maximally optimize or maximally minimize the size of that temporary storage buffer because it's so small anyway that, gaining another 10 or 20% on it is not going to matter, right? So, we were using 7K in the Sokoban game right now. If I start using a lot more, maybe we'll use up to 64K, right? 64K in a game now is a 128 by 128 texture, which is tiny. That's too small of a texture to use for anything that would even appear on the screen, right? So I think the only cases in which you want to get picky about the size of that buffer are, maybe you have a lot of threads or something. But then threads, like worker threads, usually have smaller jobs to do anyway because you want to be clear about what they're doing because thread safety is important. So we'll see. We'll see how it evolves because it's a new thing. But I don't think you want to get too picky about doing that. It's more like something you do in very obvious places. Oh, cool. Abner's going to do a NASA programming philosophy talk. That'd be great. Does the compiler give you warnings if you, for example, try to use memory from the temp storage without first checking alignment requirements? The temporary storage right now, and we may play with this a little bit, but it currently aligns to 8 bytes by default. So, there's a little bit of wastage in there. And so if you look at some of the numbers that came up during the demo, they're maybe a little higher than you would think. And it's because of the 8-byte alignment, right? So even if you're doing tiny strings, you still, you still round up. And the reason is just because you want all your data structures to work. Now, there are, if you're doing, graphics or SIMD work or whatever, there are times when you want a bigger alignment than that, like 16 bytes or even bigger. But those are very special cases, and you probably don't want to use temporary storage for those things, right? So right now, it's just intended for just regular programming language use kind of stuff. And for any of the native data types, the biggest alignment you ever need is 8 bytes. I mean, unless someone introduces a CPU where you could only have a pointer every 16 bytes, that would be nasty. All sorts of stuff would break, man. Would there be a compiler for Android eventually? why can't by type know that sign does exist, but is waiting on another type? Like, how would you do? By type is just some code that I generated in text. So like, am I going to go back and edit the text file? Am I going to put a placeholder in there and edit the text file? The thing is, my code doesn't even, I didn't want to go too deeply in this, but my code doesn't even really know that sign exists and that we're waiting for it. And you could start adding that concept, but it would get really complicated. So it doesn't seem like a good way to solve the problem by doing that. Am I required to set up a temporary storage manually every time you want to write a even small program? A library might require that. No, you get a default temporary storage at startup. So if I go into main here, right, the very first thing in main, I'm going to say print storage at startup is blah. Right, and I will have it. Oh, whoops! I've got to get rid of my placeholder foo. Right, so storage is, oh, I'm not printing the contents, I'm printing the address. Let's print the contents. Storage at startup is blah, 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 right? Which is actually the same thing we're printing later, but I'm just making it very clear. Upon entry to main, we have a valid 16K temporary storage buffer. Now, there is, okay, it is not to say there isn't an extra complication. The extra complication is if you ever use anyone's external code, you have to know whether you should, you should just reset temporary storage regularly, right? If you don't do that and you use code that uses temporary storage, then you'll have memory leaks, right? But they will log, and if you never notice that, you're probably not shipping a real program anyway. So, you know, I don't think it's a very big problem, but we'll see. We'll see if it's a problem in reality. Someone's saying, idea on preventing use after free on temp heap. Would it be possible to introspect metadata sufficiently to scan memory for pointers into temp for memory debug during development, kind of like a GCC mark phase? I haven't thought about it too carefully, but I mean, anything you can do statically, you can do in your meta program, right? So like as long as, like you can definitely see things being allocated with tprint or whatever, like with temporary storage, and you can mark that, and you can do all kinds of program analysis, right? Now, however, generalized reasoning without extra markup will only take you so far, right? So one of the reasons Rust is such a pain in the butt to program in is because it's not enough to simply to prevent all errors or all the classes of errors that they're trying to eliminate. It's not enough to just do static analysis on the equivalent of a C++ program, right? It has to be more restrictive. Right? So the same thing might happen here. Like you could probably catch a lot of low-hanging fruit errors, and those are often useful to catch, but you would not be able to catch all errors, right? Some of them the compiler would just not be able to see. But that might be fine. Like catching most errors is probably fine. You know, basically all the issues that come up with temporary storage are like the issues that come up if you use alloc-a in C or C++, except temporary storage is actually more robust because it can survive returning from a procedure, obviously. James is saying, with regard to undeclared identifiers, it seems like there should be checkpoints where you could say by this location, all names used inside module foo should be resolved. Yes, I agree. And however, I also don't want to assume, I don't want to start making that mechanism and make a complicated thing and assume that people should use it because, I mean, I would like you not to have to think about order of compilation to the greatest extent possible. So I prefer to do something like, if it is not overly restrictive, I prefer to do the mandatory placeholder thing. It's just that placeholders are so new, I don't have a feel for them. And I don't have a feel for how it's going to be if I require them. So what I want to do is a bunch more meta programming first. And then we'll see, what approaches survive are necessary. And yeah, I mean, if it makes sense then to be talking about the compilation phase of different modules like that, then I'll go ahead and generalize that facility. But for now, because I'm not sure that's the way things are going to go, I just did only what I need. Would it be beneficial to set a mark on the temp storage on a function like the player moving things? The one you showed earlier. I'm not sure I understand the question. Would it be beneficial to set a mark on the temp storage? Oh, that's the same question as, okay, never mind. Blah. If you add a placeholder for food, but then don't use or declare it, will it generate a warning that you have a superfluous placeholder? I showed that right at the end. That was this mistake thing, right? If you don't fill it in later, that's an error. How do you handle the strings from struct member accesses in the compiler when the struct has not had its definition resolved yet? What happens is those just can't be compiled yet, so they wait, right? So I said very briefly, for example, it's just like this num entity types thing, right? This just waits. So a struct is the same. Like, actually in draw, I'll do, right? We say by type, don't we? No. Right. So if I do something like this, I'm saying, look, for every issued sound entity in by type, do a thing, right? Very common gameplay code. And until by type is declared, so here's the thing. It's actually a chain of dependencies that happens. So it has the definition of entity manager, which has all this stuff. And entity manager has a by type member. So it knows that this exists. But it doesn't know what type it is, because capital by capital type has not compiled yet, right? That's the thing that we added here. So until this is provided, this can't compile. And so the compiler knows that. It gets to here, and it just says, is this ready yet? Nope, not ready yet. We got to pause compiling this function and go do something else and come back to this one later. But that's all invisible to you. You don't have to think about that. Can I elaborate on my plan on what I plan on doing with context name clashes? No, because I haven't thought about it enough yet. That was the whole point. I'm just going to live with it for a while. And then later, as other namespace facilities get decided, then we'll see if they naturally cover that result or need to be expanded to cover that result. Didn't I already have a feature that renames symbols on import? Why wouldn't that work for context extensions? Because it's not an import, right? Just referencing a struct isn't an import. So you would have to have something slightly different that could use the same renamer facility, but that says, my view of this struct has these different names or something, right? And furthermore, that would have to happen automatically for people writing to the context struct, because you just say, here's my context member. So it's just not totally clear. It can be done. I could sit down tonight and hack in some solution for that, but I want to see what's best, right? And part of knowing what's best is giving it a little time, right? We've just only now had expandable context struct, so the issue is new. So let's give it time to see exactly what the issue is before we declare a solution. The get mark, defer, reset mark construct together with allocation in the temporary storage buffer in a procedure is essentially like attaching a secondary stack to the procedure. So why not provide functionality to directly allocate on the stack and omit using the temporary storage buffer in this case in the first place? Because you can't return things. So if you have alloc A, right, that's in your local stack frame, so you can't return a result from that. So therefore, you can't use it for almost anything. right? I mean, if you're going to have people you call use that memory, you have to pass the pointer to them. And that's annoying all of a sudden, right? So the whole point of this is that the results survive for a long time. That's the entire why it exists, right? If you just want alloc A, we can do that later. We don't have it yet, but we can do it later. But no, you want things that survive through many procedure calls and that you could return out up many levels and so on. Oh, I couldn't see what he's saying because you invisoed all his things, so I can't tell if it's a legit spammer or not. I have no idea. Is there a demo where you talk about starting and deleting threads if there's any particular thing in the language about that? There is a demo where I launch a ton of threads. I don't remember exactly which one it is. Maybe someone can paste it if they remember, paste a link. But it's literally nothing special. This language has no thread-specific features yet. It's just there's a standard library wrapper for create thread, start thread, and so on. That's all it is, and it just calls the Windows or Linux equivalents for those things. Eventually, there may be some thread-specific things, but they aren't going to be like what most languages do. They'll just be things about, for example, helping ensure that your thread is thread safe in some way or another. I've ranted about this before. I think most facilities that most languages provide to help with threads are not actually helpful, especially if you care about performance, which if you don't care about performance, why are you threading in the first place? Unless you're, well, let's not dig at anybody like Rob Pike in this talk. So, yeah, I mean, there will be some things that are a little bit about threads, but I don't think they'll be threading primitives. I don't at this time even know what useful language support for threading would be. And don't say like Erlang or like Go or anything, because I don't think any of those are very helpful. The one thing that might be helpful is to say, here's a mutex. This data, this data can only be referenced when the mutex is held or something. But even that is probably only useful for super debug builds because you don't want to use mutexes on most of your complicated synchronization. And the complicated synchronization is where you need the most help. So how helpful is that? But we'll see. We have to figure it out. You know, the only language I think that really helps you with threads is Rust. And I've already said I don't want to go down the Rust path. So there is that. What if I want to over-align a 64-byte struct to 64 bytes so that it always exists on a single cache line? Well, it would be pretty easy to add a routine. You could write it yourself that says, bump the temporary storage up to the next cache line, right? It's very easy to just like allocate some amount that puts your address at the next multiple of 64 bytes. Maybe I should have thought of that and demoed it, but I didn't do it. I had a typo in the GL data struct. What? Oh, Winnow. Well, I'm not on Linux right now, so it's fine. Thank you for catching that. Why is string interpolation bad for multi-language support? Because, okay, this is not related to anything we talked about today, but what is a typical string interpolation might be something like, it's hard to think of the exact example. So I'm thinking about stuff like dates and times and all that, and that stuff gets super complicated. Like I wouldn't even be able to do it all in an example right now because you want to do different things based on what your language is. Um, but even so, there's a basic principle. Okay, let me put it this way. So I start out with some code. Let's not do anything complicated. Let's do something super basic. So I want to do what in the language today is something like, S is sprint. The name of the guy is whatever common name, right? So that is the way that I prefer to do things. So I've got the name of the guy is whatever. So if you were to do this with string interpolation, you might say like S is, quote, the name of the guy is whatever, $ name. Pick your favorite syntax for that. Doesn't matter. This would be like, if you were in Perl, or I don't know if the single quotes would confuse Perl, or maybe you would have to put curlies around it. Whatever. That's the string interpolation version. Now, the problem is, this isn't actually what's going to be in your code if you've got multi-language support, right? What's going to be in your code is the following. Let's paste these. Okay, without internationalization, right? With internationalization, hopefully I didn't spell that wrong. I don't want to put A18N. Why? With internationalization, you end up doing something like this. Well, the way I do it is, I might have some, maybe even a compile time routine, or usually a runtime routine that says, I of name string, right? And off in a database, off in a data file is mapping name string to this, or my Spanish is terrible, but el nombre del gente is, actually it would be el señor se llama, whatever. Whatever, like you'd have a different translation for every language, and some of your translators would be good and some of them would be terrible like me. I can't type this in Emacs, so I'll put whatever. Okay, so now the same thing would happen here, where you would say S is I of name string, where name string is just a tag into the data file, right? So first of all, how is your string interpolation going to even work? Like, this string would have to be available at compile time. So now I have to have all my languages baked into the executable, and I can't like pull one in at runtime, right? Or I can't add any at runtime. I can't like dynamically download one without patching the executable. So that's crazy. But suppose I did that anyway, and suppose I made this some macro, I don't know, so that it all happens at compile time, right? Well, now one day I'm going to come along and I'm going to change the name of the variable name. Maybe I shouldn't have called it name because that's confusing. I'm going to change what it's called. I have names of several things in this procedure now. So I'm going to call it guy name, right? Here it's obvious, right? Here it's a little less obvious because it's in a string, but whatever, I can see that. Down here, it's obvious still, okay? Here, the name is off somewhere in some frickin' string. Who knows where it is now? And so my code is leaking into my data, and that is not good, right? The reason you want strong compile time type checking is so that you can keep a clean separation between code and data, actually, right? Like Lisp people get excited that code is just data, right? But sometimes it's bad for code to be just data. That's my rant on why I don't like string interpolation. Totally off topic. Can there be multiple temp storage areas? Well, I certainly made multiple ones for different threads. you can definitely make a new temporary storage, just like I made for that thread, and just set it and call child code with that, right? I thought I was going to have an example of that, but maybe it's just as well that I didn't because I talked for long enough about that one topic. The thing that there doesn't really make sense is to have multiple simultaneous temporary storages for different purposes. And it's just because I feel like having one, like what matters is what people understand is the common convention, right? Because that's what enables different code to use it. And I didn't want to complicate that by having a bunch because I don't want it. I don't want people to not use it because it's annoying and complicated, right? So there's just one. That's how it goes. Someone's asking me about bootstrapping again. No, okay, I'm going to put something on the channel that if people ask me about bootstrapping or self-hosting, they get kicked. Not seriously, but it annoys me so much. Will the Sokoban game be ported to PS4? Probably. How about allocator usage blocks, like using temp allocator, default allocator is temp allocator? Yes, you can do that. And you can do that with a very small variation on what I did here. So okay, so for example here, oh wait. Yeah, I actually did this exact thing, what you're talking about, right? So I say, let's change the allocator in the context to this thing called temporary allocator. And that's the new context, and then we call messy. I glazed over messy really fast, so it may not be obvious this is what I was talking about, but this does a bunch of heap stuff, and instead we're going to have it do a bunch of temporary stuff. So you can do that with a whole library if you want. You know, you just wrap the call to it with something like this, and it all goes into temporary storage. What do I think about OpenMP? I don't think about it much. I don't understand how it's useful, really. Any plans on implementing discriminated unions? Probably not, except a special case of non-nullable pointers, but we'll see. Have I tried or used temporary storage with compare and swap or other multi-threaded concepts? Do I think this is possible or safe? You'd have to get very specific about what exactly you're doing with compare and swap. I don't have a good picture of what you're suggesting. I will say that I haven't used compare and swap very much. I may do that in the future, but it has never been exactly the solution for what I was looking to do in anything in the compiler so far. Would it be possible to release the PS4 platform layer to people who also have the PS4 partnership? I hope so, yes. That's going to be interesting because Sony probably has to approve it one way or another. So we're just going to see how that goes. Obviously, we would like to do that for sure. Maybe it's fine. I don't know. Maybe it's just fine if somebody else has signed the TLA or whatever that we can just send them the thing. I don't know. Why would I choose to extend the context versus plain old thread local storage? Well, thread local storage is I assume you mean as a global variable, right? Well, there's performance cost to thread local storage, for example, and you may not want to take that performance cost. Plus, then it normally behaves as a global variable, right? And you may want some of the local aspects of the context. So for example, because the context isn't a global variable, I can do stuff like this, right? I can change it around for the subtree, and this won't affect any other code, right? I mean, I guess you could say I'm going to write to a global variable and change it back before I return. I guess, but that's a little bit asking for trouble, I think. It is certainly not clean. Yeah. I feel like I had some other reasons that are not coming to mind right this second. Um, I mean, there's sort of cache reasons as well. Like the context is probably going to be in cache most or all of the time because it's a very common struct that lots of people touch. Whereas it's not necessarily true for arbitrary, thread local storage in global space. I feel like I had some other reasons, but it's late and I'm not remembering them right now. If anyone can think of any, they could type them into chat. Are there any plans for having a convenient C binding interface? What do you mean by convenient? I mean, I'm already using C libraries, so the question is it not convenient enough already? What is the difference between placeholders and a forward declaration in C? Well, they're a little bit simpler because placeholders, you don't have to know the type yet even, right? So it's just a name. So there's that, right? In C, you have to declare the type of the thing. Other than that, it's a similar idea, right? It's the thing is there are no forward declarations in this language at all. So this is like a little bit of a forward declaration creeping back into the language, but you only use it in very rare cases. When the time comes to rework the language syntax, how do you plan to translate with the existing code, manual rewrite, or using the metaprogramming features? I'm looking forward to it as a very robust test of the metaprogramming features, right? If you get full information on the program and where all the identifiers are and so on, then it should be very easy to write a very robust translator that moves things from an old syntax to a new syntax. So I am intentionally writing a ton of code that is going to be legacy syntax in order for that day of reckoning to come when I test the metaprogramming facilities, and if they're not up to the task, to make them stronger, right? So in the end, it should be an automated process where you just say, there'll be like converter library where you just load it, and in a couple lines of code, you pass all your code through that, and it'll just suck in all the files and turn them into the new thing. That's the plan, including preserving comments, preserving comments and all that stuff. You mentioned that the context is set as a reserved register. Actually, I didn't. It's not a reserved register right now. How does this work with multiple contexts? There aren't multiple contexts. They all get packed into the same struct, which is why there's that potential naming issue, right? If they weren't in the same struct, the names would be private, and you wouldn't have that problem. So there's that. Global variable contexts would be terrible for debugging, e.g. you can't see what the allocator was in outer scopes. That's true. I mean, you sort of could by walking the stack back and looking at things, but you're also sort of at the whim of whatever the guy who wrote that global variable patching code, however he decided to store his temporary data and all this stuff. Yeah. The syntax of changing metaprogramming might make a good programming stream. That is true, but it won't be for a while. Okay, any further final questions? I'm kind of out of voice for some reason. So last couple of questions, anything super important? Is automatic translation planned for language version upgrades post-release? Possibly, we'll have to see. Right now, I'm only thinking about release timeframe. With user-defined additions to the context, is there a risk of the mechanism becoming too magical, invisible, implicit? It seems really useful when there's a very strictly defined interface that implementers of shared code can rely on. but I can envision sloppy code with functions implicitly relying on special values existing in the context of work. Yeah, I mean, so anybody can make a bad API. And if they can make a bad API with regular arguments, then they also can with the context. So if someone does that in a library, don't use that library, right? I mean, just like you wouldn't want to use something with a terrible API. I've already said what operating systems we're targeting. Well, right now we're on Windows and Linux, and as time goes on, we will expand to more places. Yeah, in the long term, all operating systems, right? But for now, we're just, especially while things are internal, we're just focusing on a couple. Like, I work on Windows all the time, and then we're on Linux. I think maybe Josh likes Linux the most, or it's good to be on two platforms just to keep it real and make sure that you're handling platform problems, right? You don't want to calcify on only one platform. But so 2 is kind of the golden number for a while, and then eventually you do N. There is not a release time frame yet, no. Not a specific one. Yeah, private release will happen in a relatively short term. And then I can't make a time frame between private and public release because we don't know what issues are going to come up in the private release, so we just have to see. Okay, thanks everybody for coming and watching the demo. I have no idea when the next one will be now because there's not really that much material buffered up. This has been, most of what's been sitting around. Some of this is new, but, some of it is from months past. So that will encourage me to work really hard and get a bunch of new things done. So thank you, everybody, for coming. And I will let people know when the next demo is ready. I don't today know when that will be. I feel like doing a compiler size count. 38,198 lines of code. That's not bad for all the functionality that we have, considering some well-known compilers are very, very large. Thanks everybody for coming by. See y'all later.